Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 967. Numbers with same consecutive difference. Given two integers n and k, written an array of all integers of length n, where difference between every two consecutive digits is exactly k. You may return the answer in any order. Note that the integers should not have any leading zeros. Integers as 0, 2 or 0, 4, 3. So these are have the leading zeros. So these are not allowed. Okay. Let us see the examples. What is more clear? See here. N is equal to 3, which means we want to create a 3-digit number, and k is equal to 7. And every difference between those consecutive two digits, we have a difference of 7. Just see here. 181, which means what it indicates? It indicates the difference between 1 and 8 is 7, and 8 and 1 is also 7. Okay, and exactly see the all other all other results. It's also like that. The difference will be what? Always 7. It may be minus 7 or plus 7. That's not matter. But difference is what? 7. And see here, n is equal to 2, which means we want to create a 2-digit number where k is equal to 1. So the consecutive difference will be what? Only 1. So see here, everything have what? A consecutive difference of 1. So these are all my possible values. Now, how to do this? So it is simple, right? We cannot first case is we cannot start with 0. So that's the first case. Okay, what is the second case? The second case is I want to have a k difference. Okay, now we can focus on this k difference. Okay, let me take an example. If I give you 2, and k is equal to 7, and I have given a digit 2, you have to create a 3-digit number. What are the possibility you will think for this 2? Whether you can move to 1? No. You can move to 0 for this 2. The next digit for this 2 can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? These are all the possible digits for the next digit for this 2. Right? Okay. When I am observing this carefully, whether the 0 can be formed, whether the 0 and 2's difference is 7, no. This one, no. 2, no. But see here, this 9. When I am do a plus 7, so 2 plus 7 is what? 9. So I can say if a value like this 2, if it give a difference with the next digit, this next digit is question mark. Okay, if you want to give a difference of this digit, then it can be minus 7 or plus 7, right? So I can find 2 minus 7 or 2 plus 7. So these are the two possibility I have for the next number. Okay, so instead of going through all these numbers and trying the possibility, I can go for what? Only two possibility. What are they? One is 2 minus 7, another one is 2 plus 7. Simple. Okay, if I get 2 minus 7, what is my answer? It is minus 5. Here it is 9. Whether minus 5 can be added in the next digit? No. So this recursion will be don't execute. Otherwise, this possibility is not executed further. Okay, now this 9 can go for 9 minus 7 is what? Again 2. 9 plus 7 is what? 16. So whether 16 can be allowed? No. 16 cannot form the next digit. We want only one digit, but it only has 2 digits. Okay, so we can have this 2. Okay, now see here. 2, 9, 2. What is the digit? How many digits we have? 3 digits. Stop there. So 292 is our answer. For this 2 alone, we want to do for 1 to 9. Okay, because we can start with 1 to 9, right? Numbers. So I am just saying for this k difference alone. Okay. Now, do we understand how we are doing this? Okay. So I want to tell you something like, we want to check first of all if there is a number and minus k or that number plus k. So if I do a number minus k, it should be greater than or equal to 0. Then I can take that as a next digit. If it is less than or equal to 9, I can take this as for the next digit. Can you understand? So this is my condition. So this is my condition to take the next number that has a k difference. Hope you understand this. Okay. Now let us go for the main problem. See here, they are asked us to find n is equal to 3 and k is equal to 7, right? Okay. Now what are all the possibility we have? We can start with 1, We can start with 2, we can start with 3, we can start with 4, we can start with 5, we can start with 6. Say, start with 7, 8, 9. So these are all the possibility of starting, right? Okay. If I start with 1, what will be my answer? If I start with 1, what will be my answer? Okay. If I start with 1, I can go like, I can do 1 minus 7 also. I can do 1 plus 7 also. So do 1 plus 7. Here 1 minus 7. It will be what? Minus 6. It will be what? 8. Okay. If it is minus 6, can I go further? No. Stop here. If it is 8. What is my current digit? It is 8. What is my result? It will be 1, 8. Current digit is only 8. But what is my original value? It is 1, 8. Okay. Go further. For this 8, I can go for either 8 minus 7 or 8 plus 7. If I go 8 plus 7, it will be 15. Here it will be 1. So this will be not executed further. Fine. So it will be 1. So 1 is the current digit. What is the main value? It is 1, 8. Fine. Now it has how many values? It has 3 values. So I should stop there because it has 3 digits. I should stop there. So one of my answer can be 181. Can you understand this? Now come for this 2. For this 2, same trick. Just go for what can I split as? First 2 minus 7. 2 minus 7 is minus 5. 2 plus 7 is 9. Okay. This cannot go further. For this 8 again. For this 9, I can take this 9, right? So 2, 9 is my current answer. Okay. Now I can do this 9 as minus 7. If I put minus 7, it will be what? Something like 2. If I put plus 7, something like 16. So for the 16, I cannot go further. Hope you understand this, right? Come up with me. For this 2, I can go because this 2 is in my range, right? It's my range 0 to 9. So comma 2, 9, 2. Okay. So now see here, what is the number of digits? Number of digits are 3. So I should take this as our answer. Okay, take this as our answer. Now go for 3. Now 3 minus 7 is what? 3 minus 7 is something like minus 4. 3 plus 7 is what? 0. So 0 can be taken. 0 cannot taken as the first value, but can be taken, right? Okay. Now 0 can be taken, then 30 will be my current answer. Okay. Now go further. 0 minus 7 will be minus 7. 0 plus 7 will be 7. If I add this 7, it will be something like 307. Right? Oh, sorry. If I add 7 to this, it will be 10, right? Sorry. If we add 7, it will be 10, right? 10 cannot be added. Cannot be added to the next digit because we want only single digit, but we have what? Double digit. So it cannot be added. So there will be no recursion call. Sorry. Okay. Now come to this 4. 4 can be divided as what? Minus 3 and 11. This also cannot be further traversed. Okay. 5 can be divided as what? Minus 2 and 12. This also cannot be further traversed. Okay. Come to next value. 6 can be like minus 1 and here comes 13. This also not can further traverse. Okay. Now come to 7. 7 minus 7 is 0. 7 plus 7 is 14. So this cannot be further traversed. But come to 0. 0 can be further traversed. 0 minus 7 is minus 7. So when I am traversing 0, it will be 70, right? Now. 0 plus 7 is 7 and I will add this. So this cannot go further and it has what? 3 values. So this will be my answer. Okay. 707. This can also be my answer. Fine. Now coming to 8. If I take this 8 can be moved like 8 minus 1 is 7 is 1 and 8 plus 7 is 15, right? Okay. Now I cannot go like this. Now if I accept this 1, then it will be 81. Current result is 81. Okay. Again come down. Now 1 minus 7 is minus 6. 1 plus 7 is 8 again. So I cannot go further. And for this 8, I can put 181 as our current value. Right? So it has 3 digits. So it should be my answer. So 181 is also my answer. Fine. Now coming to the last iteration. What is the value? It is 9. So 9 can be divided as what? 9 minus 7 is 2. 9 plus 7 is 16. 16 cannot be further traversed. Now again 2. For this 2, I can say 9 2 will be a current value, right? Current value. Now for 2 minus 7, which is equal to minus 5, and 2 plus 7 is also 9. Again 9. So if I add this 9 to 9 will be my current value, and this cannot be further traversed. So this current value will be my answer, right? So 9 to 9 is also my answer. 9 to 9. So these all 5 are my possible answers, right? So that's why they have given in the question these all 5. Hope you understand, right? Okay. Now for this recursion, what is my function called? What is my function? Function parameters. So I can say, first of all, we need the count. What's the count? This count represent what? The number of elements it present. Okay, that's the first step. Okay. Then what is the second step? We want to keep track on what? These values. This 29, then this 292, then this 2, like that. We want to keep track. Okay. For that, I will keep val. Now I want to keep track on individual digits also. Okay. So I will take num. So this is gonna be my function parameters. Hope you understand this. Fine. Now it's time to go for what? Coding part. So see this. Def backtrack of count, val, num. I told you, right? Now, if count is equal to n minus 1, which means if I got a required digits, initially count is 0. If I got the count as 2, then I should stop, right? I should stop. Okay. Now, result dot append of val and return it. And if nums minus k is greater than or equal to 0, which means it is valid, right? If I do minus with k and it is greater than or equal to 0, then it is in range. So backtrack of count plus 1, increase the digit, and value into 10 and nums minus k. Just a math. Okay. Other than math, there is nothing. And nums minus k is also written, which is what? Which is the current digit. Next digit, but for the next recursion call, it is a current digit, right? Okay. Same thing done for n plus k also. Now, result is equal to empty list. And if k is equal to 0, then what should I take? If k is equal to 0, it is the edge case. And what should I take? If 1 is taken and n value is 3, something n value is 3 and k is equal to 0, then 1 1 1 is my answer, 2 2 2 is my answer, 3 3 3 is my answer, and 4 4 4 is my answer, as up to 9 9 9. Can you understand this? That's why I put this 2 loops and executed it. Fine. Now for I in range of 1 comma n, if k value is not equal to 0, then it comes here, right? And 1 to 10 and backtrack of 0 comma I comma I. Can you understand this? Now the result will be at resultant list, and I just written it. Let me submit it. Now I want to tell you some important thing. If I take this coding part, if I take these lines of code and let me run it for k is equal to 0, then what will I get the output? See here, if n is equal to 3 and k is equal to 0, I get what is the output? 1 1 1 1 1 1 1 1 1 1 1 1 is repeated 14. Why it is so? Let us analyze. See here, if I have 1 and k is equal to 3, okay, and sorry, k is equal to 0 and n is equal to 3. First of all, first step, I will go down. It will be what? 1 1, and again I will go down. It will be what? 1 1, because 1 minus 0 is again 1. 1 plus 0 is again 1. So I will add it. Okay, again it will be 1 1 1. Here also 1 1 1. Here also 1 1 1. Here also 1 1 1. So at last I will get how many digits? 1 2 3 4. So 4 count I will get, but I want to get only 1 count. Okay, to get only 1 count, if k value is equal to 0, then I should not take the second recursion call. If I don't take the second recursion call, this will be eliminated, and also this will be eliminated. Only this is executed and this is executed, right? So I will get only 1 1 1 1 time. Can you understand this? Okay, let me tell you this in code. See here, I will make this as yes. If k is not equal to 0 and this condition that it is, just do it. Let me run it. Yes. Do you observe this? Now it is not like we want to give here only. Just I remove this. Now let me give down k is not equal to 0 and let me submit this. Let me run it. Yes, see here. Do you understand? We want to just terminate only one recursion call such that it will be executed successfully. Let me submit it. Yes, it is submitted successfully. Now it's time to see the time constant space constant. So my time constant will be O of, so we are iterating for 9 times into 2 power n. So we have a 2 possibility. One possibility we can have plus k, and then we have minus k. We have a 2 possibility for each and every digit. So we have 2 power n. So n is what? Number of digits. For one digit we can have plus k and minus k. So that's the time constant. And what is the space constant? I can say space function will be O of n. Why O of n? You may ask, why O of n? Because see here, first of all, I just take this one and move to this recursion call and move to this recursion call. So 3 values will be stored in recursion stack. Now again I will go to this so that this recursion stack, see here, 1, then 1 1, then 1 1 1 for this, and then this will be deleted and it comes back to this 1 1, then it goes to this 1 1 1, so that again 1 1 1 will be created, so that the recursion stack will be only O of n. It is not O of 2 power n. Can you understand this? Okay, this can be also written as only 2 power n also. That's also correct. So this is my time and space function analysis. Thank you.